Effective IT operations depend upon the ability to monitor system activities, maintain agreed service performance, and ensure the integrity and availability of enterprise data. As organizations increasingly rely on complex digital infrastructures, operational log management, IT service level management, SLM, and database management become essential governance disciplines that support operational excellence, cybersecurity, regulatory compliance, and business resilience. Within the CISA framework, IS auditors assess whether these processes provide sufficient visibility, accountability, and control to maintain reliable and secure IT services. Operational log management. Operational logs are chronological records generated by operating systems, applications, databases, network devices, security appliances, and cloud platforms that document system activities and events. Log management is the process of collecting, storing, protecting, analyzing, and retaining these records to support operational monitoring, troubleshooting, security investigations, compliance reporting, and forensic analysis. Logs typically record user authentication event, system startup and shutdown activities, configuration changes, administrative actions, application errors, database transactions, network connection, security alerts, backup and recovery operations. Well-managed logs provide an audit trail that enables organizations to reconstruct events following incidents and identify unauthorized activities. Operational log management follows several key processes: log generation and collection, time synchronization, centralized, aggregation, secure storage, monitoring and analysis, retention and archival, disposal according to policy. Time synchronization across systems is particularly important because inconsistent timestamps significantly complicate forensic investigations and incident reconstruction. Modern organizations frequently centralize logging through security information and event management (SIEM) platforms, which collect events from multiple systems, correlate suspicious activities, and generate automated alerts for security and operational teams. Continuous monitoring supports proactive detection of abnormal behavior before significant business disruption occurs. From a governance perspective, logs should be protected against unauthorized modification, deletion, or disclosure. Access should be restricted to authorized personnel, while retention periods should satisfy legal, regulatory, and business requirements. Organizations should also periodically review logging configurations to ensure that critical events are captured while avoiding excessive storage of unnecessary information. In conclusion, auditors evaluate whether logging is comprehensive, synchronized, protected, regularly reviewed, and capable of supporting incident response, regulatory compliance, and operational accountability. IT Service Level Management. IT Service Level Management, SLM, is the process of defining, monitoring, measuring, and improving IT services to ensure that they satisfy agreed business requirements. Service level management aligns IT operations with organizational objectives by establishing measurable expectations for service quality and availability. The primary governance instrument is the Service Level Agreement, SLA, a formal agreement between the IT service provider and the business customer specifying expected service performance and responsibilities. Typical SLA metrics include system availability, response time, incident resolution time, recovery time, transaction throughput, backup completion, service desk responsiveness, maintenance windows. Supporting agreements such as operational level agreements, OLAs, and underpinning contracts, UCs, define responsibilities among internal IT teams and external vendors to ensure SLA achievement. Effective SLM follows a continuous improvement cycle. Service definition SLA negotiation, performance measurement, reporting, service review, corrective action, continuous improvement. Performance monitoring utilizes key performance indicators, KPIs, and service dashboards to evaluate whether operational targets are consistently achieved. Deviations trigger management review and corrective actions to restore agreed service quality. The IT service desk plays a central role by coordinating incidents, service requests, communications, and escalation activities while serving as the primary interface between users and IT operations. The service desk also supports related ITSM processes including change management, configuration management, availability management, and incident management. IS auditors examine SLA documentation, performance reports, service reviews, escalation procedures, customer satisfaction metrics, and continuous improvement initiatives to determine whether IT services effectively support business objectives and contractual obligations. Database management. Databases form the foundation of enterprise information systems by storing operational, financial, customer, and strategic information essential for business operations. Database management encompasses the administration, security, performance optimization, backup, recovery, and governance of database management systems, DBMS, throughout their lifecycle. Database administrators, DBAs, are responsible for database installation and configuration, user access management, backup and recovery, performance tuning, capacity planning, patch management, replication, and high availability security monitoring. Because databases contain highly sensitive information, access control is a fundamental governance requirement. Authentication, authorization, least privilege, role-based access control, encryption, and audit logging help prevent unauthorized access and modification of enterprise data. Audit logging within databases records transactions, administrative actions, and structural changes, enabling organizations to monitor privileged activities and investigate unauthorized modifications. Database logging therefore supports both security monitoring and regulatory compliance. Configuration management is equally important because DBMS platforms contain numerous configuration parameters affecting performance, security, and reliability. Organizations should centrally manage database configurations and compare production settings against documented standards to maintain consistency across environments. Similarly, database changes should follow formal change management procedures involving request, review, approval, testing, implementation, and documentation before production deployment. Database capacity management ensures sufficient storage and processing resources to support growing business data while maintaining acceptable performance levels. Auditors review capacity planning procedures, utilization reports, and growth forecasts to determine whether management proactively addresses future storage requirements. In conclusion, operational log management, IT service level management, and database management collectively provide essential operational controls that strengthen monitoring, accountability, service quality, data integrity, and business resilience. Effective implementation of these disciplines enables organizations to maintain secure, reliable, and high-performing information systems while supporting governance, regulatory compliance, and continuous operational improvement.